the liquid of density rho 1. So what the liquid will do, will exert force, will exert force. There's a one best problem I have picked up. What are these arrows? These arrows indicate the force exerted by the now why the arrows here? There's the force exerted by the liquid on the cone. And it will also exert force here. I think I have placed like this. I'll show it here. Look at the length of arrows. Blue color and red color arrows are different. I think this is one property of liquid. Pressure varies with the depth. On the base or depend, the pressure everywhere is same. So the liquid will exert a force like this here. Now, what are these red colors? Red color arrows are force exerted by the liquid on the slant face. What about the blue color arrows? Force exerted by liquid on the base. So this I will call slant face. This called like a bottom. In turn, what will happen? The cone will also exert equal and opposite force, and the action of that what happen? The liquid is at rest. Am I right? So I'm thinking in other way now. So I've shown the force exerted by the liquid on the cone. So this is a light cone. Cone will not have any mass. Light cone is telling. So let's take the. You have to really dig a lot. Means you have to draw the diagrams, think on lights. So shall we take like this here? No. So in turn, the cone will, what is this? This is a liquid column. Huh? I think here, this is the liquid. What I have is not a cone, liquid column it is now. Liquid filled up in a cone. On the liquid, how the forces will be acting? The forces acting will be these are time consuming problems. Huh? Little bit we have to. In turn, the bottom will also exert force. I think I do. And the weight of the liquid. I think I have what all, everything I'm showing it. So this is the liquid rho 1. What is the radius of this 2r? So these are the forces acting liquid column. What is the state of liquid column in equilibrium? What is this? Liquid column, not a cone. Cone with liquid I'm showing. There's only liquid column. Under action of all the forces, it's in equilibrium. So therefore net force on it should be 0. So the resultant force exerted by the cone on the liquid will be vertically down. By the cone, it's like a slant faces. If you look at the slant faces, the net force exerted by slant faces on the liquid column will be vertically down. The force exerted by the base on the liquid column will be vertically up. I think these are the two important statements I am uttering. Please, the net force exerted by the slant face on the liquid column will be vertically down. The net force exerted by the base on the liquid column will be vertically up under action of the weight of the liquid and force on the slant face and also on the bottom. And the action of all this, it will be in equilibrium. Net force along x-axis should be 0. Along y-axis also should be 0. We'll equate along y-axis here. Got the idea? So I think this, if you can think this much, you can do something you can do in the problem. Otherwise, not possible. Okay, now let's get into this one. So on the liquid column, I'll write it by cone on liquid. What is this? By cone on liquid. Equilibrium of liquid column. At equilibrium of liquid column. So what are the forces that are acting? So this will exert a force P1 into A, and the net force exerted by that, let me call that as F1, and it will be directed vertically down. Who is that? Force exerted by the cone on the liquid column. So what are the forces? I'll write it here. P1A minus weight of the liquid minus F1Y equal to 0. P1A, what is the pressure at a depth 2h? How much it should be? Rho 1 G 2h. What is the area? Pi r square. Minus weight of the liquid column. Total weight, what is the weight of the cone? Weight of this, so this should be equal to 1 by 3 pi r square 2h into G. Volume of the liquid in the cone. That's what the weight of the liquid. Minus F1y equal to 0. Density is missing. Density, I'll write it here. Rho 1. Okay, look at this. All the simplification. 2, 3, how much will get it? Four by 3 F1y. So this should be equal to 4 by 3 pi rho 1 h cube. What h cube? No, not h cube. It is r square. Check calculation. Where r equal to h. Later on I'll substitute. Where r equal to h. Where r is equal to h. Okay, this I think. Okay, fine. So this will become h cube. It will become rho 1 h cube by g. Okay, this is what is F1y you should call? Net force exerted by the cone on the liquid column along y-axis here. So what is this F1y you should write? Net force exerted by cone, not force, vertical force. 5 by 3 you'll get it. Check calculation. I think 2, 2, 3, 3, 2, just 6, 6, 5 by 3. Yeah.
Sir, 4 by 3 only, sir.
4 by 3 only. Yeah?
Yes, sir.
4 by 3 only. Okay. So what I should call this F1y? By the slant face, no force exerted by the slant face of the cone on the liquid, not net force. I think we should not go for this one. Or total resultant, it should be.
Sir,
Yeah.
sir, can you explain the calculation, sir? I'm getting another answer.
H equal to R per radius. Radius is R and height is 2h. Finish work. Force exerted by the cone on the liquid. So now what is this? This in equilibrium, no? So in equilibrium, what are all the forces that will be acting? The liquid will exert a force. I'll come back to the first diagram. The liquid which is inside the cone will exert a force, and that is what F1, and that F1 we are calculating. And how it will be F1y up vertically up. I think directly I'll come to the problem. So this will be F1y. The liquid inside will exert a force on the cone. Okay, that is F1y. Clear this? That's the resultant. Then the liquid which is there outside will exert a force. The liquid which is there outside will exert a force. That will call F2 here. I think I'll have to show it F2. F1y is what I calculated. Force exerted by the liquid on the liquid inside on the cone. Now similarly, we'll calculate F2y. How to calculate F2y? Again, I'll go for the previous particular thing. Here, I think just make observation. I'll finish off this problem now. Huh? Now come for this one. So there's a liquid 2. Now this part is what? The IT is how much? This will be H. And this is R. This is R. And this is H. This liquid which is there will exert a force, no? Here. Those who are able to understand this, it's a very simple. Huh? The idea is what you have to grasp it here. A net force exerted by the liquid which is there outside density rho 2 will exert a force. And how it will be directed downward. So shall I put everything here, F2y, that I'm showing at only one place here. How to calculate this F2y? Weight of that liquid. How to calculate the weight of the liquid? Pi r square. So this is H. Only I think, okay, I think I have to take it only till here, no? It should be, the forces still be like this and all. Okay, no? This part is what? Its weight is what you have to find out. Just no previous problem, what I did, the same analogy I'm using. That's why I just picked up two problems here. The weight of this blue color liquid, which is there outside the cone, that is what you have to take that one. How to calculate that particular volume. So shall I go for like this? So what is the, it will become like a cylindrical disc of height h and radius h. Okay, no. No, I think it's pure geometry, yeah? Nothing to do. I give this concepts. How to find out that one? Total volume will calculate. So only thing is pi r square h, the weight of that particular thing. Pi r square h in that F2 is equal to pi r square h. Later on h I'll write equal to r only. Rho into pi r square h g. Rho g I think I'll bring outside. Pi r square h. Then how to bring this particular volume in the total volume of bigger volume? Shall we remove this smaller part of volume, the shaded volume? Vishwas, switch off video. Vishwas, switch off your video. Yeah. So now in the bigger volume, 1/3 pi r square 2h. In that you subtract another smaller volume, smaller cone. Solve this, you'll get the weight of the, what is this F2? Weight of the blue color liquid lying beside cone. Anybody simplify and just tell it.
2 by
So
3
sorry.
pi r square.
So
H.
wait. This should be r by 2. R by 2. R by 2. Radius of this will be r by 2. What is this? I will do one thing. I will shade this much of volume. I should subtract in the bigger cone. No? I don't have much explanation, everything based on the diagram, because I can't do anything else. And what is this? This is a bigger cone like this. Fine. And this particular pi r square h is this particular thing, blue color one. Anybody value?
7 pi r square h by 12 into rho g.
7 will come. Huh? Check it once. 7 will not be there.
Sir, 5 by 12, sir. 5 by 12 pi r
Sir,
square.
5 by 12.
Pi r square h rho g, where h is equal to r. So 5 by 12 pi h cube rho g. Okay, this is f2y, which the ratio of this is what he's asking. Okay, I think I'm giving some diagrams all. Just make observation. I'll go for the next one. So he's asking the ratio of this one. No? So either f1 by f2y. Do this. Now, what is f1 by f2y? Should be equal, no? It's in equilibrium. I think, let me wind up the problem. Some are asking, sir, how answer will come. At equilibrium of cone f1y is equal to f2y. Equate these two, you'll get the density. What are the densities? Rho 2. Symbols is a problem. So many are there. Yeah. Try to see all this. So we'll get a ratio of rho 1 by rho 2. I'll write answer. Check it later on. You have to verify the calculation part. I'll move to the next one. So this is, we can do by integration. I'm trying to avoid. Later on Friday, we'll focus on how to integrate things. One problem I have